polyethylene polymer, low density polyethylene and high density polyethylene. Okay, so these are the characteristics of LDPE, low density polyethylene, and the uses of broad uses of LDPE. Okay, then this was the pre-radical mechanism of LDPE polyethylene, low density polyethylene polymer synthesis: initiation, propagation, chain termination. And the chain termination can be done by two ways: mutual interaction and disproportional reaction. Okay, and then the manufacturing procedure of LDPE. First of all, you have to prepare the raw material, that means ethylene. We can prepare ethylene by using different techniques: dehydration of ethanol, dehydrogenation of ethyl chloride, and the controlled hydrogenation of acetylene, but not general hydrogenation. In the case of general hydrogenation, acetylene react with hydrogen to produce the ethylene, and this ethylene will be spontaneously converted to ethane. But if we want to use the controlled hydrogenation, then we can get ethylene from the acetylene. Okay, and this is a schematic diagram, flow sheet diagram for the manufacturing of LDPE. Next one was HDPE, high density polyethylene, and this is the mechanism of high density polyethylene, and these are the different uses of high density polyethylene. And finally, the manufacturing procedure of HDPE. Now, I'm going to talk about the different types of polyethylene. First one is polyvinyl chloride, PVC. This very famous plastic polyvinyl chloride PVC pipe. Do you know? Response, please.
Yes, sir.
Okay, so among all the plastic polymers, PVC is most widely used as construction material. Construction material, that means if you want to build up a high-rise building, there are many types of pipe and different types of sanitary wire we have to use. So PVC pipe is very most commonly used construction material. It is prepared from the monomer of vinyl chloride, which is commercially prepared by the catalytic addition of hydrogen chloride. This is another hydrogenation reaction, catalytic hydrogenation. For example, hydrogen chloride to acetylene. This is the acetylene, HCl. Hydrogen chloride reacts with acetylene in the presence of charcoal catalyst, in the presence of mercury, to form the vinyl chloride. That means CH2 double bond CHCl. This is the vinyl chloride, and the polymerization of vinyl chloride is called PVC, polyvinyl chloride. Okay. So at first you have to prepare the vinyl chloride from the acetylene with the reaction of hydrogen chloride in the presence of charcoal catalyst and mercury. Okay, so can you understand this reaction? HCl reacts with acetylene to form the vinyl chloride. You have to understand or remember that this is the structure of vinyl chloride: CH2 double bond CHCl. Okay. Now, the polymerization of vinyl chloride is carried out by using hydrogen peroxide as the initiator. Do you know what is initiator? Can you tell me? Any student, what is the function of initiator in the free radical mechanism or polymerization reaction? Can you tell me? Anyone? Please response. Initiator. What is the function of initiator? Any student can tell me?
Sir, it is like the essential reagent which is required for the polymerization.
Okay, so this is the reagent or something that can start the reaction. Initiator, initiation, understand? That start the reaction and also propagation, understand? So this is called initiator. That means initiation means start the reaction. Initiator is the function to start the reaction. Okay. So in this reaction, polymerization of vinyl chloride, hydrogen peroxide acts as initiator. Then this is the polymer PVC, polyvinyl chloride. Okay, so this is a simple reaction to form PVC polymer from the vinyl chloride. Okay, in the presence of hydrogen peroxide, and hydrogen peroxide acts as initiator for this reaction. Okay. Now, the properties of PVC. PVC is hard and amorphous powder. It is characterized by its excellent flame resistance and low cost. It's a very good characteristic, excellent flame resistance. Okay. and low cost, PVC can be extruded to pipes of different dimensions. So we can prepare different types of pipe which has different types of dimension by using PVC polyvinyl chloride. It can be compressed into thin sheet. We have also prepared thin sheet. PVC sheet are used for the manufacturing of tank lining, safety helmet, trays, bicycle or motorcycle mud guard, etc. To manufacture flexible PVC, plasticizer are added. So if we want to prepare the flexible PVC, then plasticizer are added. And I already discussed the function of plasticizer in the case of polymerization. Okay, to produce the flexibility and plasticity character, we have to use the plasticizer in the case of synthesis of polymer. Okay. The commonly used plasticizer are dioctyl phthalate, dibutyl phthalate, tricrystal phosphate, etc. These are organic or inorganic compound. Okay. The plasticized PVC are used for the wire coating, for sheeting of electric cable, film and tubing, etc. PVC containing low percentage of plasticizer are used in the injection molding for manufacturing household articles, toys, toothbrush handles, etc. So this is the uses of PVC plastic. Okay, the main uses to prepare different types of pipe that we have to use for the construction of building material. Okay, and also to prepare the PVC sheet. By using this PVC sheet, we have to prepare different types of article. For example, tank lining, safety helmet, trays, bicycle, motorcycle, mud guard, etc. And also different types of household article, toys, toothbrush, cup, uh, hanger, or different types of household articles. So this is the broad uses of PVC plastic. Okay. So PVC polymer, that this chapter is very much related to the plastic material. So rubber and not so rubber, just plastic material, PVC same. Okay, so we have to prepare different types of plastic material by using the polymerization technique, different types of technique. Okay, the first one is polyvinyl chloride. Okay, and this is the example. Different types of pipe. This is the soft flexible pipe, and this is hard pipe. And can you understand? This is flexible and this is hard. So to prepare the flexible pipe, we have to use, what is this? What is this? Plasticizer. Okay. Understand?
So,
Okay. So can I go to the next one?
so,
Okay. Response, please. Only one student respond. This is not good. Nylon 66. Okay. So nylon 6 is a copolymer obtained from the polymerization of two monomers. First one is adipic acid. Second one is hexamethylene diamine. Diamine. So first one adipic acid and hexamethylene diamine. There's a little bit missed. Sorry, adipic acid. This is the adipic acid and this is hexamethylene diamine. Okay, this is the complete reaction. Adipic acid reacts with hexamethylene diamine to form the nylon 66 or 66 plus water. It's a condensation polymer. Do you know? Do you remember that this condensation polymerization? So can you tell me the definition of condensation polymerization? Polycondensation. Please. Response. For condensation polymerization that I already discussed in my previous class. Any student response, please. Condensation polymerization.
The condensation polymerization is when an acid, carboxylic acid and amine react to give water and one polymer chain.
Okay, not only carboxylic acid and amine. Condensation polymerization is little bit okay to remove the 1 mole of small molecule such as water, methanol, or HF, these types of molecule, ammonia. Okay, so reaction between two monomer or co-monomer to form a long chain polymer by the removal of small molecules such as water, methanol, HF. This polymerization is called condensation polymerization. Okay, that means the removal of small molecules. Okay. Now, nylon 66 has characteristic property of both plastic and fiber. So it has two character, plastic and fiber. Okay, it has high strength, elasticity, toughness, and abrasive resistance. It is insoluble in most common solvent. Insoluble most common solvents. Strong acid degrade it into some extent. Strong acid means sulfuric acid or concentrated nitric acid, concentrated sulfuric acid. Degrade it to some extent. It does not absorb moisture. Okay, it does not absorb moisture. Due to the presence of polar group in the molecule, it is used as electrical insulator or restricted to low frequently ones. This polar group in here also, this group is polar, you know. Why this group is polar? Can you tell me? This is the this electron will be shift to this. Okay. So this will be partial negative and carbon will be partial positive. So this is the polar, you know, this also polar group. Understand? Okay. Can you understand why this is polar group present in here? This polar group present in here. Response, please. Do you know the electronegativity of oxygen is higher compared to the carbon? So the electron will be shifted to the oxygen and it will acquire partial negative charge, and carbon will acquire partial positive charge. That's why this group is polar always. Okay, and this group also polar. This group also a little bit polar. Okay, understand? Response, please. Student, can you hear me?
Yes, sir. I can hear.
Okay. So it is used to electrical insulator are restricted to low frequency only, and okay. So the most important application are manufacturing of tire, cord, ropes, thread. This is the rope. Different types. This cords have high density and good elasticity because of its high tensile and impact strength, high temperature stability, good abrasion resistance, self-lubricating, and ball-bearing properties. A ball-bearing property. It is also used as substitute of metal in ball-bearing and gears also. Sometimes it is used as substituted of metal in ball-bearing gear or gear, etc. This is the nylon 66 is very hard and high strength, and also it has some elasticity, proper toughness, and abrasive resistance. It is insoluble in most commonly solvents, strong acid, and some strong acid degrade to a little bit extent, but it is not absorb the moisture due to the presence of polar group. Okay, can you hear me, student? Sorry. Hello.
Yes, we can hear you.
Okay. So the most important applications are manufacturing of tire, cords, ropes, threads. The cords have high density and good elasticity because of its high tensile and impact. Okay. Because of its high tensile and impact strength, high temperature stability, and good abrasive resistance, self-lubricating and ball-bearing properties also. So this is the use. These are the use of these types of 966 to prepare these, and also these types of particle, and different types of tough particle that is high strength. That is high strength and toughness. These types of polymer will be used for the preparation of these types of article. Okay, and another example is bakelite plastic. This is also important. By using these types, bakelite plastic is used for the preparation of large type article. For example, bakelite is a phenol formaldehyde resin. Phenol formaldehyde resin formed by the condensation polymers. So do you know what is phenol? Benzene structure contain one OH group. Okay, phenol. And formaldehyde HCHO, the first member of aldehyde series. Okay. Polymerization between condensation polymerization between phenol and formaldehyde. It is a grafted copolymer, and the nature and properties of the polymer depend on many factors, such as the composition. So what will the composition of phenol and formaldehyde? Molar ratio of the reactant. Number 2, nature of the catalyst, acidic or basic. This is the basic, ammonium hydroxide. Do you know the basic environment reaction? Okay. And number 3 is temperature. So there are 3 factors that greatly influence the preparation of bakelite plastic. First one is nature of composition of the reactant. That means the phenol and formaldehyde. What will be the composition? Phenol 1:1 or 1:2 or 2:2 something. And second one is nature of the catalyst. So catalyst may be acidic or basic. So in here the catalyst is basic, ammonium hydroxide. And third one is temperature. So what will be the temperature of the reaction? If the ratio of phenol to formaldehyde is greater than 1, the reaction proceeds in almost linear fashion. This is the fact. If the ratio of phenol to formaldehyde is greater than 1, the reaction proceeds in almost linear fashion. If the ratio is less than 1, an alkaline catalyst is used, then a 3-dimensional network structure is produced. This is the 3-dimensional network, and this is linear. Okay.
Yeah.
So can you understand the speech? If the ratio of phenol to formaldehyde is greater than 1, then the reaction proceeds in almost linear fashion. But if the ratio is less than 1, an alkaline catalyst is used. Then a 3-dimensional network structure is produced. So first one is linear structure, second one is 3-dimensional network structure. This is very complex structure. So it depends on the condition of the reactant ratio. If the ratio of the phenol with formaldehyde is greater than 1, then linear structure will be formed. And if the ratio is less than 1, then alkaline catalyst is also used, and the 3-dimensional network structure is produced. These are the 2 examples. Okay. Bakelite has high stability and resistance to cold flow. These are widely used because of their good dielectric properties. Phenolic resins are used for the impregnating paper, wood, and other substances as a filler for producing decorative laminates and wall covering. So we have to use these types. There are many types of articles that we are using in our decorative purpose in the construction, apartment, or building. Then this is the phenolic resins are used for impregnating paper, wood, and other substances as fillers for producing decorative laminates and wall covering. So nowadays we are using different types of wall covering or laminate paper. By using these types of polymerization technique, we have to prepare different types of decorative or colorful laminates or wall covering by using the pigment or dye. So if you want to prepare the decorative or colorful plastic or these types of material, then you have to use the pigments or dyes, coloring agent. Okay, so the use of this bakelite plastic used to prepare different types of decorative laminates or wall covering. Okay, it has wide applications such as water soluble adhesive, water soluble adhesive, laminating adhesives, varnish, lacquer. So this is the main important use of this water soluble adhesives that were used for our coloring of our building material, laminating adhesive, varnish, and lacquer. Bakelite has excellent adhesive properties and bonding strength, and hence used as varnish and protective coating. So it is very important application of bakelite plastic, that excellent adhesive property. Due to the excellent adhesive properties and bonding strength, that is used as varnish and protective coatings. Okay, these are also used in the production of ion exchange resin with variety of functional groups such as amines, sulfonic acid, hydroxy, and phosphoric acid. So basically, the main uses of bakelite plastic is to produce the different types of decorative laminates or wall covering, and also it has a good use in the case of water soluble adhesive, laminating adhesive, varnish, and lacquer. And due to the adhesive excellent adhesive properties and bonding strength, it is used as varnish and protective coating. Okay, and in also the production of ion exchange resin. Ion exchange resin means the exchange of ion, positive ion exchange by cation, or anion or negative ion exchange by cation. So this is called ion exchange process. Resins with variety of functional group. It has many functional group, which so functional group, benzene structure, which hydroxyl group, and O group also. So due to the presence of benzene structure, we can easily replace this hydrogen, this hydrogen, this, and this by using different types of functional groups. Okay, such as amine, sulfonic acid, hydroxy, or phosphoric acid. Okay. So is there any question about the bakelite? Student, please ask me. Any question about that? Please ask me. Response, please. Student, can you hear me?
Yes, sir.
Okay, next one. Melamine. Okay, melamine is a copolymer of formaldehyde. So basically, it is a polymerization of formaldehyde. It is an organic base and a trimer of cyanamide. Organic base and trimer of cyanamide with 1,3,5 triazine skeleton. 1,3,5 triazine skeleton structure. Urea formaldehyde and melamine formaldehyde resins are very much similar in their production and application. These are popular known as melamine. It can be prepared from calcium carbide and nitrogen by the following reaction. So calcium carbide reacts with nitrogen in the presence of sulfuric acid to form hydrogen H2 and NH2CN, and OH. Then after this reaction, dicyanamide. Dicyanamide is CN and this C double bond N, dicyanamide. And after that, the polymerization of this dicyanamide, it will convert it to melamine. And also another process, melamine can also be prepared from urea simple by heating in the presence of ammonia. So do you know the structure of urea? NH2CO NH2. Can you tell me, is this organic or inorganic compound, urea? Student, is this organic or inorganic compound? Urea is a organic or inorganic?
Organic compound, sir.
Basically, it's organic compound. We can produce this compound by heating ammonium cyanide. Okay. So by using this, melamine can also be prepared from urea simply by heating in the presence of ammonia. This is the urea. By heating with ammonia, we can prepare this. This two-step reaction. Methyl cyanide, sorry, ammonium cyanide. After this ammonium cyanide and also this compound, then the three molecules ammonium cyanide reacts with from this structure. In the case of this also, calcium carbide reacts with in the presence of sulfuric acid to form ammonium cyanide. Then at 100 degree centigrade temperature, the basic condition after the reaction, dicyanamide will be formed. After that, dicyanamide will be polymerized to form this compound melamine. So this is a melamine is a copolymer of formaldehyde. Basically, we have to use to prepare this. It is also organic base and trimer-cyanamide with 1,3,5 triazoscalicon. This is the 1,3,5 triazine. Triazine. This is the 1, 2, 3, 1, 3, 1, 1, 2, 3, 4, 5. 1,3,5 triazine skeleton. Okay. Now, melamine reacts with formaldehyde in slightly alkaline condition to yield methylol derivatives. This melamine reacts with formaldehyde in the presence of basic condition to form diallyl melamine, diethylol melamine, and also this, This is the different types of compound. And by using this reaction, we have to prepare different types of melamine product or plastic product. And characteristic, the tensile strength and hardness of urea or melamine resin are somewhat better than those of phenolic resin. The melamine resin have better hardness, heat resistance, and moisture resistance than urea. Relatively more expensive melamine. And melamine resins are extensively used for the production of decorative lamination and for the production of procaries. This is the basic use nowadays. There are a lot of procaries item that is made by just simply melamine. Okay. This is the basic, very important use of melamine now. So is there any question about that? Student, just you have to study from the book and also this slide, just short note or discuss the following topic. These types of question will come maybe. Okay. So discuss the following things that in melamine, bakelite, nylon 66 or PVC. Then you have to write down the what is PVC, what is the raw material, what is the reaction, what is the characteristics, and what is the use. First of all, you have to mention that what is nylon 66, then how can you prepare this, then what will be the raw materials, how can you prepare the raw materials, then the characteristics of nylon 66, and finally basically the uses of nylon 66. So this is the way how you can write the answer of this. Okay. Next one is dacron or terylene. Dacron is a polyester fiber obtained by the condensation. This is also condensation, polymerization between the dicarboxylic acid and a dihydric alcohol. Dihydric alcohol, do you know, ethylene glycol. So can you tell me how can you prepare the ethylene glycol? Which reaction? This very famous reaction of alkene. Glycol is the product. So which reaction? Can you tell me? Organic chemistry alkene chapter. So do you know the Beer test for the identification of unsaturation present in the organic compound? Carbon-carbon double bond, Beer test. Can you tell me?
Yes, sir.
Okay. So what is the condition of Beer test? Alkene reacts with which reagent? Coal
potassium
potassium.
permanganate and potassium hydroxide.
Coal potassium permanganate. You have to mention the cold. Okay. Coal potassium permanganate. Then product will be glycol, ethylene. So ethene reacts with potassium permanganate in cold condition and potassium hydroxide. Then ethylene glycol will be formed. So Dacron is a condensation polymerization between the dicarboxylic acid and dihydric alcohol, ethylene glycol. At 260 to 300 degrees centigrade temperature, removal of NH2O. Okay, this is the structure of Dacron, and this is the polyester. So ester group, you know, RCO, RCO, O, R. This is ester. RCOOR, CO, COO. Is the ester group. Okay, understand? That means the skeleton structure, main structure of the Dacron contain which group? Please respond. Which group? Ester group. RCOR. That means this part is our COOR. Okay, understand?
Yes, sir.
Okay. Now, Dacron is Dacron is heavier yarn. Its specific gravity is higher than that of nylon 66. It is a good elasticity. It has good resistance to weak acid and base, but strong acid and base rarely attack it. It has moderate heat resistance and is attacked by any kind of microorganism. It is moderate resistance, heat resistance, and it is attacked by any kinds of microorganism, bacteria, virus. It is flammable without spreading fire. It is attacked by UV or near ultraviolet region of light. Dacron is used extensively as the material of garments fabric, such as shirting, suiting, making socks, blankets, sweater. It is also used for making aeroplane tires, wire insulator, and parachute cloths. Understand? The very important use is dramatically the widely used as a material of garments fabric, such as shirting, suiting, making socks, blankets, sweater. So this is the very important material for the garments fabric industry. Understand? Shirting, suiting, making socks and blanket and sweater. It is also used for the making aeroplane tires, wire insulator, parachute clothes. This is the very important use of Dacron because it has some heat resistance, moderate heat resistance, attacked by any kind of microorganism. That's why our garments product destroyed after some times. Understand? Because this product can be attacked by microorganism, and it is also attacked by UV light. That's why some garments product they lose their characteristics or shininess if we keep it in a very high temperature or in the presence of UV light or sunlight for a long time. Understand? Okay, Dacron, can you understand, student? It is
Yes, sir.
Dacron product, it's a polymer. And next one is Teflon. What is this? Teflon is the polymer of tetrafluoroethylene. Tetrafluoroethylene, that means CH3, CH, tetrafluoroethylene. This is the structure. Tetrafluoro. CH, C double bond C, 2 fluorine, tetrafluoroethylene. Okay. So tetrafluoroethylene is known as tetra. So polymerization of this tetrafluoroethylene is called Teflon, and it's called polytetrafluoroethylene. The monomer tetrafluoroethylene is prepared by pyrolysis or thermal cracking using chlorodifluoromethane, chloro and chlorine difluoro. And do you know what is pyrolysis? Can you tell me? Pyrolysis What is pyrolysis? Any student can tell me? Pyrolysis is a reaction in which one compound will be converted to the smaller part in the presence of air with a high temperature. Cracking of compound. Cracking means breaking. Okay. Cracking of a compound in the absence of air at high temperature. This is called pyrolysis or thermal cracking. Understand? So if we use in the air, then thermal cracking or pyrolysis will not be occurred. So if you want to occur the pyrolysis process, that you must the system absence of air. Understand? This reaction will be carried out in the absence of air at high temperature, 600 to 750 degrees centigrade temperature. Understand? What is pyrolysis or thermal cracking?
Yes, sir.
Okay. So tetrafluoroethylene on emulsion polymerization by oxygen gives a plastic material Teflon on exceptional characteristics. Which characteristics? Teflon is a linear chain polymer. Teflon is a giant molecule having high regular structure without branching or cross-linking. It has no branching or cross-linking. It's a linear polymer. Okay. As a result, Teflon fiber has very high density. Teflon chain are crowded in the polymeric molecules. They have densely populated and strongly held fluorine atoms all the chain. So in the structure of the Teflon, many fluorine atoms will be attached. Fluorine atoms all through the chain. As a result, Teflon fiber has high chemical resistance and exceptional resistance to strong corrosive media such as acid, base, and oxidizing agent. As fluorine, many fluorine atoms present in this structure. Teflon is also thermally stable up to 325 degrees centigrade and low water absorption capacity. It's thermally stable. So uses of Teflon. Teflon is widely used in the pump, packing, stuff bearing, cable insulation. It is also used for the insulation of motor, generator, transformer coil, capacitor. Small equipment such as gaskets, bulb parts, mold release device are made of Teflon. It is also used as a coating material in the non-stick frying pan. So non-stick frying pan, you know, in our kitchen where you frequently use non-stick frying pan, Teflon is very good use. It's very important use of Teflon is that coating material is a. So now we are using different types of frying pan. Non-stick frying pan is very popular in our kitchen, popular item. So the coating, the upper size coating is sometimes using Teflon, so widely used. Coating material as a non-stick fry pan. The non-stick fry pan is not good. Non-stick, very good non-stick is okay, but normal non-stick fry pan is not good because it is contain this structure, fluorine, and also this molecule. So if we use the non-stick fry pan or non-stick article for a long time, then maybe the coating will be removed and it will be mixed with our food and go to our stomach, and also we have to attack different types of diseases. That's why my suggestion is that please don't use frequently non-stick fry pan for a long time. And if you want to use the non-stick fry pan for cooking purpose, then please try to use a good quality fry pan, non-stick fry pan. Otherwise, you have to use the silver fry pan or the aluminum fry pan. Okay. Because after some time, after 1 year or 6 months or 2 months, then this Teflon coating will be removed, must removed. Okay. Next one, last topic is plastic polymer. What is this? Plastic polymers may be defined as a polymer which can be molded or given shape by applying heat and pressure. Plastic of various properties available nowadays. The following properties are lightweight, low thermal electric conductance, resistance to the action of water and heat, easy of fabrication, because by fabrication means to prepare different types of different shape article. High corrosion resistance, resistance to the attack of small insect microorganisms like fungi, moths, high resistance to the action of light and oils, high resistance to abrasion, transparent as oil and translucent, low coefficient of thermal expansion, low melting point, but high refractive index, good shock absorber. impermeable to water and other requires low maintenance cost, do not require protective coating. So in that case, don't require protective coating, plastic polymer. Good mechanical properties and good ability to mix with pigments and other additives. This is a very important part. Good ability to mix with other pigments and other additives. So by using these different types of pigments and other additives, we have to prepare different types of colorful or fantastic polymeric article or plastic product. And this is the last topic for this chapter. So our next quiz will be held on next Friday on this chapter. Just I want to review this chapter. First of all, you have to read the what is polymer and the characteristics of polymer. Then the broad classification of polymer based on degree of polymerization, depending on the source, based on structure, organic and inorganic, depend upon the mechanical properties, depend on ultimate use and form, then based on composition, and then classification of based on polymerization. Okay. Then synthesis of polymerization for addition, free radical, ionic, condensation polymerization, and ring opening and oxidative. Okay. Then polymer processing by additive binders, fillers, dyes, plasticization, and lubricant. You should read each and every ingredient with a specific use. Okay. Then polyethylene polymer, it is categorized in two types, LDP and HDP. LDP, the characteristics of LDP and preparation and use and the mechanism, okay, and ultimate manufacturing process. Same as HDP, the characteristics and the mechanism and also the manufacturing process. And finally, different types of polymeric compound. So if you want to study these types of polymeric compound, first of all, you have to study the what is this, what is PVC, what is the raw material, how we can prepare the raw material, what is the reaction, what type of reaction it is, then the characteristics of PVC, and finally the ultimate use. Okay, PVC, nylon 66, bakelite, melamine, Dacron, Teflon, and finally plastic polymer. Okay, so please take and good preparation for the next quiz, inshallah. Okay. Now I have another class from 8 AM for IT students, so I have to call the attendance. So please respond first. Section A student. Can you hear me, student? Please respond. Section A student.
Yeah. We can hear you.
Okay, ID 1, section A, mechanical ID 1. 3.
Present, sir.
7. 11. 12. 13.
Present, sir.
14. 13. Okay. 12, 13. Okay. 15. 17. 18.
Present, sir. 17 present, sir.
Okay. 18. You may leave. Okay.
Yes,
Section
18.
student, after completion attendance, you may leave. Okay. 18.
Yes, sir.
19.
Yes, sir.
20. 21. 22. 24. 26. 28. 30. 31.
Yes, sir.
32.
Present, sir.
33.
Present, sir.
34. 35.
Yes, sir.
34.
Sir, 34.
Okay. Yes. Okay. 35. 36.
Yes, sir.
38.
Present, sir.
39.
39 present, sir.
Yes. 40.
Yes, sir.
42. 43.
Yes, sir. 43.
44.
Yes, sir. 44, sir.
45.
Yes, sir. 45.